This video is about acid and carbonate reactions. So what happens when you put an acid with a carbonate. So we'll start with a little example of NO3 minus HNO3 nitric acid and calcium carbonate. So a carbonate is any ionic substance that has a carbonate section. So you have a metal cation like calcium here, which is a 2+, write that up there, and you have a carbonate ion, which is 2-, right, calcium carbonate. Sodium carbonate, lithium carbonate, any metal with a carbonate ion is what we mean when we say carbonate. And the reason that this is important is because sometimes you want to look after your carbonates. So calcium carbonate, this example, is what a large proportion of your bone mass is made of. And you want to make sure that you don't erode it by drinking too many fizzy drinks that are full of acid, or too much caffeine, too many of those energy drinks that we keep telling you is bad for you. The acids in those things can leach the calcium out of your bones and cause things like osteoporosis, and the calcium can collect in your kidneys. You end up with kidney stones, which I am told is the definition of torture, to have those kidney stones leave your body. So you want your carbonates to stay in your bones. So the other thing, calcium carbonate is used to make marble monuments to, important people and mythological things, headstones, that kind of stuff. Here's an example of a marble statue before and after nitric acid fell from the sky and eroded it. So it's got dates in there, 1908 to 1968, that's the difference. So nitric acid comes from industrial pollutions that when it mixes, sometimes with the nitrates in the air pollution mixes with rain, and it makes the rain slightly acidic. Slightly acidic rain is enough to make the calcium carbonate wear away, like this one. Sometimes you actually want to get rid of your carbonates if they're in your kettle, because the carbonate buildup in the kettle that comes from the water, leaches out of the water. That stuff actually draws a lot of energy, so it means that you're using more electricity to heat your water, because you're also heating this stone coating on your kettle. So you might want to know about acid carbonate reactions when it comes to cleaning that up. My dad used to put lemon juice in the kettle. And, no one wants to shower under a stalactite. Here's some more calcium carbonate. Then you want to clean that up, right? So you want to know that acids wear away calcium carbonate for whatever reason. So like your acid-base reactions, and that's kind of what this is really, you have this kind of swap. So this cation and this anion will join together to make a salt. And nitrate is -1, so I'm going to need 2 of those. So I'll end up with calcium. No, I got that wrong. I wonder if I can rub that out. There's only 1 calcium and 2 nitrates. Calcium nitrate, and then the other anion-cation pair, so the carbonate and the hydrogen will go together, and you might think you're going to get, because H is +1, carbonate's -2, you might think you're going to get H2CO3, which is carbonic acid. And carbonic acid is what's in your soft drink, actually. It's only survives like that under pressure, which is why when you take the lid off your soft drink, the carbonic acid turns into carbon dioxide, which comes out as fizziness in your drink, and water. Right, so you don't actually get carbonic acid, not unless you're doing this under high pressure. So you get a salt. So acid plus carbonate gives a salt. In this case, it's calcium nitrate plus CO2 plus H2O. So if you were going to put an acid with a carbonate, you might observe, let's get another colour. You might observe bubbles being formed, like when you open your soft drink. And that's how you know one of the signs that you know a reaction is taking place. So you get salt, carbon dioxide, and water every time you put an acid with a carbonate. And if you can't remember what the products are going to be, just do this, colour in the H, the NO3, colour that in, swap it around and see what's left over. So we also have to balance this equation. So let's have a look. We've got one hydrogen on the left and I see two hydrogens on the right. So I'm going to need to put a 2 over here. Right, you can only add, you can't take away. So the only way to fix this is to increase the number of hydrogens on the left. I've now got 2 nitrates on the left. I've got 2 nitrates on the right. That's perfect. 1 calcium here, 1 calcium here, 1 CO2, let's say. There's a CO2 and there's an extra O here, and there it is over there. So if you counted them up, how many H's, how many N's, how many O's, you'd find there's the same amount on each side. So it's balanced. So we're going to do one more example. Here we go. Sulfuric acid and sodium carbonate. So we're going to get the metal here and we're going to use it to make a salt with the anion, the negative part of the acid.